Welcome to Homework Lib.
So here we have the circuit, and these are the capacitors: 8 microfarad, 6 microfarad, 2 microfarad, and 8 microfarad connected here. And we need to find out the total capacitance of this circuit. So as these two capacitors are connected in parallel, so we will effectively use the expression for the capacitances connected in parallel. It will be C1 plus C2, and for the capacitances in series we'll use C1 C2 by C1 plus C2. So as these two capacitors are in parallel, so the net capacitance here will be 6 plus 2, that is 8 microfarad, and this 8 and this 8 and this 8, these three capacitors are now connected in series. So the net capacitance will be now 1 by C1 plus 1 by C2 plus 1 by C3 is equal to 1 by C in series. So here we put the values, we get 1 by Cs as 1 by 8 plus 1 by 8 plus 1 by 8, so into 3 times. So this gives us the capacitances as 8 by 3. So this is the net capacitance of the given circuit here. Okay, so this is the net capacitance. And let us find out on each capacitor what will be the charge. So as we have figured out the net capacitance, the total voltage applied here is 9 volt. Voltage source is 9 volt. So we know that charge will be C into V. This is the net charge which will be emitted from the battery. It will be 8 by 3 into 9, that is 24 microcoulomb, because we have taken in microfarad. So this is the charge which is emitted by the battery, 24 microcoulomb. So on this capacitor, the charge will be 24 microcoulomb only. So this plate will have plus 24, this will have minus 24. Similarly, this plate here will have minus 24 microcoulomb, and here we'll have plus 24 microcoulomb charge. And here the charge will be divided, and in what ratio it will be divided, let us figure out that. So basically 24 microcoulomb charge is coming out here, and these two capacitors, they are in parallel. So if we use the expression q is equal to cv, so in parallel we have the voltage which is constant. So that means q is directly proportional to the capacitance of the branch. That means this 24 microcoulomb, it has to be divided in the ratio of the capacitances. So here these capacitances, they are in the ratio 3 and 1. So charge, we have to send 3 part of charge out of 4 from this 24 microcoulomb, and through here 1/4 will only flow. So this will be 6 microcoulomb, and this will be 18 microcoulomb. So we get that the charge through 6 microfarad will be 18 microcoulomb, and charge through this 2 microfarad will be 6 microcoulomb. And let us also compute in this circuit the difference in potential across each capacitor. So once we have figured out the charge, so let us redraw this quite more effectively. So we had 8 microfarad here and connected to 6 microfarad, and here we had 2 microfarad in parallel, and we had 8 microfarad here as well, and this was connected to the source 9 volt. And the charge that we obtained was 24 microcoulomb deposited on this capacitor, 24 microcoulomb deposited on this capacitor as well, and then 18 microcoulomb here and 6 microcoulomb here on this capacitor. So once we have the value of C and Q, then we can get the voltage difference across the capacitor. To find the voltage, we will use Q is equal to CV. So we have Q and C, so V will be Q by C. So here Q by C, so 18 by 6, so that will be 3 volt, and across this capacitor we will have 6 by 2, that is 3 volt, because, and it should be same because they are in parallel. Across this capacitor voltage will be Q by C, that is 24 by 8, and this is 3 volt, and here also it will be 3 volt because total supplied was 9 volt. 3 was applied across this capacitor, 3 was applied across these two terminals, so total 6, and remaining 3 volt will be applied across this capacitors.